Our world is facing a great challenge. Fossil resources are limited, and increased greenhouse gas emissions are accelerating climate change. To combat this trend, the EU aims to be climate neutral by 2050. This requires major reductions in greenhouse gas emissions and more efficient technologies and processes. Our project provides a breakthrough technology for the process industry. The EU-funded project, MACBETH, created a highly efficient catalytic membrane reactor. It combines the catalytic synthesis step and the separation step using a tailor-made membrane. In the project, 27 partners from 10 countries joined forces: industry leaders, research organizations, and universities. The MACBETH project addressed 4 key chemical processes: hydroformylation, hydrogen production, propane dehydrogenation, and biocatalytic oil cleavage. Hydroformylation is the conversion of olefins and syngas to aldehydes to produce specialty chemicals.
The aim of our project case is the demonstration of a heterogeneous hydroformylation in the gas phase performed in an integrated membrane reactor, which enables the separation of the aldehyde from the reaction zone. We designed, constructed and run our new integrated membrane reactor at a demonstrator level, fully implemented inside of a production plant successfully. After now having implemented our technology in the framework of a production plant, we definitely will go further our path to commercialize this technology. Together with our academic partners and our great network we developed during this phase, we will also proceed further, and we will there focus on investigations on a basic research level.
The next chemical process is hydrogen production line from biogas or natural gas.
The goal of the hydrogen line within the MACBETH project is to demonstrate the membrane reactor technology for reforming of biogas and natural gas at an industrial level. With this technology, we aim to make an impact on the hydrogen production sector towards a more sustainable future. Currently, 2 prototypes for hydrogen production via membrane reactor technology are being demonstrated in an operational environment. Palladium-based membranes are conventionally supported on a ceramic-based substrate. However, ceramics are fragile and they tend to fail or break. We wanted to reproduce such membranes on a metallic support instead, to make them stronger. During my PhD, I developed a preparation procedure for these newly metallic supported palladium-based membranes. I then demonstrated their applicability in a membrane reactor for reforming of methane.
The third chemical process is propane dehydrogenation, the conversion of propane to propylene to produce petrochemicals.
The main goal of propane dehydrogenation activities in MACBETH project is to integrate palladium-based membranes for efficient hydrogen separation and also develop a new stable catalyst for longer catalyst regeneration cycles. A new platinum tin-based catalyst is developed, providing lower coke yields and higher propylene selectivity near to the thermodynamic limits of the reaction. Increased propylene yields per pass and longer catalyst life will make a great impact in the market and potentially decrease the production cost of propylene. 3 different organizations, Turkish Petroleum Refineries Corporation, University of Salerno and Eindhoven University of Technology are working with 3 different reactor configurations for this purpose together with kinetics technology, NextChem and Tecnalia.
The last case is biocatalytical oil cleavage.
The BOC case, which stands for biocatalytic oil cleavage, is the most exotic part of the MACBETH project. We explored the applicability of the catalytic membrane reactor concept to the field of biotechnology. The main challenge we had to overcome was the transition from a gas phase reaction, as in the other 3 cases, to a process where the reaction takes place in the liquid phase. We were also behind in terms of the initial development phase. While the other 3 cases already had an existing pilot plant from previous EU-funded project, we basically started from scratch. But with the expertise and experience of such a strong consortium, we were able to overcome these hurdles and develop a process that uses both enzyme catalysis and membrane separation technology to enrich omega-3 fatty acids in fish oil. This novel technology could have a major impact on the downstream processing of waste fish oil with low omega-3 content. Further potential can be realized through enzyme engineering and AI-driven approaches to increase the selectivity of the biocatalyst even further.
During the project, the spin-off company Modelta was founded.
Modelta is a modeling service provider specialized in membrane technology. We identify existing and new processes where membranes and membrane reactors could play a crucial role and build models to be able to accurately predict its added value compared to conventional technologies. This we do in terms of process efficiency, but also costs and emissions. Modelta was created within MACBETH as an entity that commercializes the know-how created in the project. This project was the ideal starting point as we have developed strong collaborations with many of the necessary building block providers, such as membrane manufacturers, catalyst providers, EPC contractors, and all the different parties needed to implement this technology. As a result, we are able to provide many different reaction and separation solutions in sectors such as the chemical industry, the energy sector, the water treatment sector, food and beverages. Modelta, together with partners, has actually created a commercial modeling tool and database which is necessary to do analysis and to do modeling predictions. Our aim is to become a lighthouse, creating a roadmap and helping companies with making informed decisions when it comes to implementation of membrane and membrane reactor technology for a more sustainable future.
With the MACBETH project, the European Union gave us the great opportunity to work on 4 cases in a very powerful network to employ membrane reactors to change production towards more sustainability.
MACBETH makes it possible to reduce emissions from the process industry to achieve the goal of a climate-neutral future.